23 years in this industry. I shouldn't have written that. I feel really old now. So, based on what I just heard from Dr. Wang, I'm going to have to be prepared for a whole load of questions about ARM against Intel, what's happening with Microsoft. So, we might as well just forget the presentation, we just cut to the Q&A. Dr. Wang said she had 12 questions about where we were with Windows. So actually, to make it even more controversial, my day-to-day job is actually to actually focus on taking ARM into the server and the data center market. So, but we'll talk about that later. But today we wanted to talk a little bit about what ARM's view was on what was going on in the embedded market. There's a lot of stuff going on about tablets right now. You know, really, it's quite a small market. 50 million units estimated this year or so. Anybody know roughly what the estimate is for number of microcontrollers to be shipped this year? About 10 billion units. Okay, so very, very big market into a whole broad range of applications and types of technologies. So, wanted to spend a little bit of time talking about that, ignoring any fights with Intel or anything like that, and then that will happen in the Q&A. Okay. The other bit that I'm really nervous is my face was really built for radio, so I'm a little worried about that photo at the end there because I didn't do my face this morning. I just flew in from Europe yesterday, so I'm unshaven and stuff. So we actually break down the embedded market into a few strata, and you know, embedded computing, these are the sorts of processors that you find in an ATM machine or digital signage, that kind of thing. So it's typically a processor running a big operating system like Linux or Windows, that kind of thing. And then we break out MCUs into different areas. At the very low end, there are MCUs that are typically sold on price. I mean, there are some people now selling 32-bit microcontrollers for 65 cents through distribution and making money, which is absolutely incredible to me. And then down at the low end, you've got 8-bit microcontrollers for 10 cents, 12 cents kind of thing. So really, really cheap. And you can see the sorts of places where they're going in. The gentleman from Semi was talking about where lighting is going. This is one of the places where people are looking at putting intelligence into the next set of lighting solutions. Then there's the general purpose MCUs, an MCU that's in there in a Zigbee controller, various types of wireless, heating, ventilation systems, that kind of stuff. And then at the high end, you see more performance-driven MCUs. We see people that are building MCUs in automotive with megabytes upon megabytes of flash next to it. Sometimes because they're actually wanting storage right by the chip in the event of an accident, because then you can sort of download all the things of what went wrong and that kind of stuff. But very much performance-driven MCUs. So we're seeing 400 or 500 megahertz MCUs, megabytes upon megabytes of flash right by it, and typically those guys are on a very leading-edge process node for the MCU market. They're pretty much wherever you can get the best MCU flash is where you're going to go. So where do we think these markets are going? So typically the high end, these guys tend to lag the what's going on in the computer market by a couple of years, that type of number. So in the ARM world, people like NVIDIA, right? They bring out the Tegra device. It's in a whole load of netbooks right now. But they're taking the same technology, they're doing extra qualifications. They might, to Dr. Wang's point, change a couple of IPs because, a touchscreen user interface, which is really good in a netbook, might not be quite so relevant if you're in a car, because if you're driving like this, you probably shouldn't be going like this on your system, right? You might have more voice-activated things, you might have different IOs for around the car, that kind of thing. So you typically take the same building block, TI does the same thing, and roll it in to the next generation of these embedded applications. Like NVIDIA, TI typically do that because they spend quite a bit of money on what I've now learned that we make is blue salt. So they pay a lot for our blue salt, and they want to get the most out of it.
You can't use it.
Hmm?
It's mine.
Oh, okay. we will be in court later. So typically these guys are driven, there's a big drive on frequency here, and you can see our estimates on process node and where memory is going. Again, for everything that we've got up here, you can probably find 5 or 6 different exceptions here, but just a rough idea of what we see going on. Typically at the low end, we aren't seeing frequencies go, it's all down about how do you get cost out. And you see there's still a lot of people on really relatively old process nodes. And we don't see that changing. They'll just take capacity, and if there happens to be a lot of capacity on 180 nanometer in 2015, they'll go there because that's the most important thing in their world. So we do see in the 32-bit area, of those 10 billion-ish units that are shipped in the MCU space, really only about 10% of them are 32-bit today. Okay? An ASP just over $4. So the size of the markets from a dollar perspective turn out to be about the same between 8, 16, and 32. But there's a lot more units of 8-bit shipped, and obviously microchips are a significant leader in that space. But we are seeing a shift. One reason, algorithm complexity is getting more complicated. So we've seen in touchscreens where the initial panels are punching like this. I want to click here, I want to click here, click here. A lot of people have seen what Apple have done around the iPad and said, you know what, I want these fancy things where I can stretch the screen, pull this, do something else with my fingers on a much bigger screen. And that's gathered some momentum since Windows 7 was announced, because Windows 7 has touchscreen support. So we're seeing a lot of the vendors that used to supply relatively simple touchscreen controllers like Synaptics, Atmel, Cypress, those sorts of guys saying, you know what, our algorithms are getting more complicated because our customers want to do fancy stuff with their fingers on a big screen. Second thing is integration of multiple subsystems into one. So for example, in some washing machines, you've historically had 3 processor subsystems. Processor is a very extravagant word. Nothing nearly as sophisticated as Intel would make, just a very basic 8-bit DSP sometimes, or an MCU, but they are looking to integrate those down for cost. We see the same thing happening in smart meters, where at the moment you have 3 processor subsystems in a smart meter. One that's measuring the flow of electricity or the flow of water or gas through a particular pipe, and then you've got the main one that's doing the calculation of what does that mean to the system, and then you've got one that's doing the communication back to the infrastructure, either Zigbee if you're here in the US, or a lot of power line if you're out in China and certain parts of Europe. So the idea is, well, I've got 3 subsystems, can I go integrate into one? And we don't think it will go into one quickly, because there's still differences between whether it's not all going to go to power line, there's different flavors of power line, so we don't see it all collapsing down right now, but clearly there's a drive, and as soon as you drive down multiple systems into 1 or 2, you need more performance. And then the other thing is that you start to see these systems that were black boxes wanting to be connected. And, you know, when I didn't have quite so much grey hair, I was in the DSL market. And, yeah, I know, it was a long time ago. What they did was they started to put out these DSL gateways. And the problem is when you do that, you start to deploy it out, and then people learn about what they want to do with their products. And so you actually have to build in. At the time, EchoStar in their satellite market, and also we saw in the DSL guys, were shipping these systems with about 30% of the CPU utilized, just because they knew they were going to need something else in the box at some point. They just didn't know what it was going to be. So we're seeing these people that suddenly are, you know, I'm going to have to reserve some horsepower and some capabilities here. I don't know what it's going to be for, but it's obviously a significant deal, because to actually go and replace a unit at a house, it's a big cost, and all the support and things like that. So you've really got to make these systems robust and somewhat future-proofing, even though, to Dr. Wang's point earlier, you sometimes don't know what they're going to be doing in 3 years. You've got to just take your best shot at it. And we are seeing people move from fixed algorithms on an 8-bit MCU to doing programming in software. So a lot of the new washing machines that are actually being developed are now controlling the drum and the rotation of the drum in software now, as opposed to a more hardware-oriented, hardwired solution. And they found that they can control the drum, spin it in different ways based on different loading, far more efficiently to save power, than if you're doing it on an 8-bit microcontroller. So the algorithm itself, yeah, don't probably need masses of horsepower, but being able to write your program in C and change it and do things like that, much easier. Now, one of the things that's happening is that as soon as you get to these nice, beautiful, connected things, everybody in this room, of course, is nice, genuine engineers, but there are some evil people out there. Now, I was born in 1965. Again, I probably look older. But so in the early 70s, you know, me and my brother, if we were wanting to disrupt people, we would pick up our phone and pretend to be the King of England and make a phone call. Hey, this is the King of England. We want some fish and chips, right? That was about our level of disruption. Now there are really people out there that are saying, you know what, let's try and take out a power station. And so, you know, if we're looking at 10 years out, or if there's people saying, you know what, I'm looking for a next career, what do I think people are going to be worrying about? I think security is going to be a massive issue. Now, we as ARM don't think we didn't have $7.4 billion, so we didn't go and buy McAfee like Intel. But I think what it does show is Intel absolutely recognized this challenge, and there's going to be a lot of people that focus on this interface between hardware and software as being really, really key for a bunch of applications. Whether you're in a car and you've now got connected car applications, right? Well, you probably don't want somebody in the back seat messing around with the brake, okay? At least I hope you don't, okay? All sorts of smart grid infrastructure as they start to put on these services. This is going to be a massive issue. And again, you don't know exactly where it's going to go, but people and new businesses will exist in 10 years from now that aren't there today solving this problem in different areas of the network. So, like we talked about, MCUs everywhere. I think probably, you know, just showing a few of the ARM MCU licensees. Obviously, Microchip is the largest 8-bit microcontroller shipper on the planet, doing very well with the PIC. You have Renesas shipping a lot of their proprietary technology out. You know, they're really going into a lot of different things. This is I can't remember this one. I think this is a charging station for currently for doing things like buying your tickets and things. But we're seeing a lot of people now with electric vehicles seeing new charging station kinds of applications. And I'll talk about a couple of areas where we see the real growth coming. Here, we certainly see that most of these appliances are now moving to a 32-bit MCU, at least one. And now as they start to look at where the smart grid goes, they're worrying about more functionality for connectivity around the home. So this was just an example of what I talked about, touchscreen controller, where people that have historically just worried about punching on buttons, they've kind of got built up and excited and really come up with new ideas because of what the iPhone is capable of. And people saying, you know what, I want that type of functionality if I'm going to go buy a ticket at a train station, or I want this thing if I'm in a security office, or if I'm a security guard mapping things. I don't want to hit button this for that camera. I want to, you know, maybe zoom in or zoom out. I want to do image recognition. I want to do all those sorts of things. Massive growth opportunity for our industry. Smart meters, there's been a lot written about smart meters. We're excited about it. But for me, the meters themselves are kind of okay. But what we're really excited about what is actually going to connect to these meters. So any of you that are in PG&E area here, you know, the Silver Spring deployments, those are actually currently got an ARM7 and amongst a bunch of other stuff. And as they go to these two-way meters, so this AMI, instead of just being an automated reading and sending your, in some cases, incorrect calculated score back to the infrastructure, this is starting to say, you know what, I'm not going to run my washing machine now, I'm going to run it in the middle of the night because it's cheaper. Or if you've got your solar panel, do you take your power from the solar panel, from the battery, or from the grid? Starting to make much more educated decisions over time. But we do see a massive opportunity about what's going to connect around these networks now. I'm with my next one. Yeah, and one is medical. And again, if we look further out, I'm absolutely convinced that this area is going to become a massive opportunity for electronics. And I think there's early people starting to mess around with electronics to do corrective eye-related things, which is interesting. There's obviously some issues. A number of companies don't want to actually supply technology into something that's keeping somebody alive or not because of liability issues and things. But we certainly see a path where electronics is going to play time in doing blood pressure management, heart rate management. Everywhere across the world, medical systems are struggling with extra people that people that are living older, people are less healthy than they were, mainly because if they're like my child, they spend more time on Facebook than they do running out on the street and playing games and activity and things like that. So there are some massive challenges here, and we see now that these smart grids are going to start. You're going to start to see people connecting medical devices, so you get discharged from your house, from your hospital. They'll be monitoring you, and if the doctor sees changes or a particular body vital goes out of a window, you're going to get an alert and that kind of thing. Okay. There are about 300 or so million streetlights around the world. We again see that this is another area where the collective intelligence of people like in this room and others, we're going to bring technology to solve some of these carbon footprint issues that exist in the world. And a number of things that we can do here. I mean, some people, yes, they're changing out the lamp just completely for a new type of technology. But seeing ways to actually, instead of just blindly switching on the device on and off, switching it progressively on. And actually changing how you do lighting at different times of the day and that kind of thing. Some very interesting studies recently where people were working out whether it's better to have certain areas lit or dark, right? So if you're selling cars and you've got big area cars, you want your lights on at night because you don't want people coming on. But they were doing studies on, is it better to have lights outside a nightclub when people come out, or is it better to have it dark because then maybe people just disperse? Lots of things going on, and if you have this capability across the grid, I think there's going to be some very interesting things you could do. All of it's going to need technology, all of it's going to be connected around a grid, and all of it's going to have to start worrying about the security aspects that I described earlier. And then at the embedded computing area, again, we see the technology building in, and I think this is sort of one area where, there's clearly lots of atom technology out there right now, and all of this investment that's being done around these tablets and all the software around Android, we're starting to see that increasingly become, Android-based ATM machines or Android-based whatever else, medical things, right? And it's not because it's just really the power of all that software, all that ecosystem that Dr. Wang described, all that software that exists around Windows. Yeah, it's not a complete computer, but I can pull all these software pieces off enough so I have a base system and then I can go differentiate from there. So hopefully it's given you a flavor of some of the things we see going on. We see the smart grid as exciting, but less about the meters, but what's going to actually connect around it. Big issues around security for that, and I think big opportunities for all. No one architecture can fit into this space and totally dominate it, nor should it. Thanks very much for your time.
Let's open our floor for question for Ian. I just realized the light went out when he's talking about the light.
It had something to it.
Thank you for coming, Mr. Ferguson. I have a quick question. Does ARM have a plan to do something like AMD? In other words, instead of just because right now I'm focusing on the business machine, kind of processor only. But then would there be a chance or opportunity for ARMs to also integrate the graphic? Because right now, a lot of the application you're talking about, especially you show above, have to do with graphic interface and also the display.
Yeah, so we do have a graphics line of intellectual property that we provide. We're behind in the market to Imagination, who's the leading supplier of IP. But we are absolutely looking at graphics, and we do believe that a lot of these subsystems is going to need not just 2 suppliers or 3 suppliers, but like Dr. Wang was saying, if you just have general IP, Unless you can start to think, how does all that stuff combine really efficiently, you're going to see that the size of your technology and the performance of it is going to be suboptimal. So we are looking at solving a number of blocks on site in these things. So we do have graphics acceleration. We've been looking at video, although what Google has started to talk about with HTML5 has started to say we should start to look at that in a slightly different way. We were planning to go off and do things like H.264, encode, decode, that kind of path. And the Google announcements kind of made us sort of pause and think a little bit about video. But absolutely, we're selling a product line that we call Mali, a number of licensees. Again, starting in the mobile phone area, we've started to see a few set-top box guys take it, but a relatively modest performance area, certainly nothing that's doing massive rendering on a server in real time like an NVIDIA thing or like the ATI graphics.
Thank you.
Any other questions?
Come on, you can give me a hard question.
You and I need to take that outside.
Oh. Wow. So yeah, actually Dr. Wang applied for a job in my group. Sorry.
Hi, Ian. So, kind of two questions. For development of product using your processors, and do you have something? Do you have plans to help the developer to be able to choose sections of their code that need performance? Maybe an engine, and put that over into hardware. Or is that something you kind of leaving up to the Xilinxes and Alteras and others to do? So that's one question. And second, about power. I mean, a lot of these are very power conscious products. And what do you offer the developer for, say, power profiling and modeling?
Yeah, so I mean, so take the latter one. We do have quite a suite of power management tools. So we typically provide quite a lot of technology through our tools group and models and things that allow you to see how our core will perform with different loads and things like that. In terms of, sorry, the first question was, oh yeah, so trade-offs between hardware and software. That one's kind of hard for us just because we provide a relatively small piece of the system. So what typically we've done, if you look at with Xilinx, we've provided our models and our power and performance information into their environment. They integrate it because they know what's going to go on in their programmable logic and what else they have around the system and how they connect it. And they're then providing it to their customers. So we're kind of putting our technology in around the scenes. But for any end customer, it's going to have to be based on what the end SoC looks like as opposed to the core. It's going to be the better answer. So that you'll typically see that stuff from a Xilinx or an Altera.
I don't know how to phrase this question. I know the problem. Let me try it. Regarding application, so you offer ARM core with multiprocessor. You also offer a small core. So in application, I think there's a competition coming up between use central computing to do everything, using multi-core processor, or distribute some computing to a localized small ARM core. One of the applications in cell phone mobile space is the sensor fusion coming up. So for multiple sensors, ideally we like to create a small ARM core to do computing only to address all the sensing signals and fusing the data to get a better performance. On the other hand, the baseband guy continue to offer a free additional computation power so that try to prevent sensor guys go to this fusion architecture. Because once we do the fusion, we can then own the software as opposed to individual component we sell to the cell phone that we give away the software for free. So in your perspective, what does ARM see, or what is your experience with this?
Well, I think that's at the point where we say we're out, we empower the market and we let the market decide. I can see those sorts of trade-offs. We see those sort of competitions and fights between.
So if you adjust your licensing model, maybe you can favor one versus the other.
Yeah, we are trying to do. I mean, the question I thought Ralph was going to ask was like, would ARM ever go like AMD and go after Intel and make chips? And I would say over my dead body, right? A, we're not very good at it. Okay. And B, it really destroys the whole value about ARM. I mean, we're out there about providing technology and allowing customers that understand how to do value and innovation outside the processor far better than us, whether it's NVIDIA's graphics, whether it's baseband technology from Qualcomm, whether it's DSP stuff from TI, whatever it might be. So in your area, maybe I didn't answer the question right, but I think in that area, we'd struggle to provide an opinion there because I think that's down on a path where we shouldn't be guiding that.
Any more? So, thank you, Ian.
Thank you.
So this one can only change to present like the show appreciation.